Okay, so today we're talking about section 4.5, the converse of the Pythagorean theorem. In part 1 it says plug in A, B, and C into the Pythagorean theorem to verify that the triangle below is a right triangle by showing that both sides of the equation are equal. We know from yesterday's lesson that the Pythagorean theorem can only be used for a right triangle. So if this statement is not true for the triangle, it cannot be a right triangle. So let's test it out. Let's plug in the points that are already labeled here, or the measures that are already labeled here. C is 5, so 5 squared. A is 3, so 3 squared. And B is 4, so 4 squared. Now notice there are no variables here, so we're not solving for anything. We're just seeing if the left-hand side matches the right-hand side. So we get 25 equals 9 plus 16. So 25 equals 25. So it did check out. So since 25 equals 25, since this is an equal sign and it is true, this is indeed a right triangle because the Pythagorean theorem works, and the Pythagorean theorem can only be used for right triangles. Okay, so let's look below in part 2. It says plug A, B, and C into the Pythagorean theorem for each triangle. Determine the sign that goes into the box, equal, less than, or greater than. So for the first box on the left-hand side here, this is an acute triangle because all of the angles are acute. This is an obtuse triangle because you have one angle that is obtuse. Okay, so let's test it and see what happens here. There's a box there because we don't know if it's going to be equal. We're trying to figure that part out. So C is 7. A is 5, B is 6. Simplify it down so we get 49, 25 plus 36, 49, and then this is 61 if you combine like terms. So we see that 49 is not equal to 61, so this cannot possibly be a right triangle. 49 happens to be less than 61. Okay, let's look at the obtuse triangle now. We'll plug in C, which is 4, plug in A, plug in B, so we get 16, 4 plus 9, and we see that 16 is greater than 13. It is not equal, so it cannot be a right triangle. Okay, so let's kind of summarize here. If a triangle is right, then C squared has to equal A squared plus B squared. But if a triangle is acute, then C squared is going to be less than A squared plus B squared. And if it's obtuse, C squared is going to be greater than A squared plus B squared. Now notice, if you did A squared plus B squared equals C squared, all of those signs would be backwards. So for sake of this, we are not going to use A squared plus B squared equals C squared because then our symbols don't really make sense. They would be backwards. Okay, so let's use those rules to classify these next three triangles. The first one, 2, 5, and 6. Now here's the key to this. The longest side has to be C. There is no other option. It doesn't matter what order they list them in. The longest side has to be C because we're going to test and see if that's the hypotenuse. So C squared equals A squared plus B squared. And we are testing this, so if you prefer to put a box there, you may. So we'd have 6 squared, 2 squared, and 5 squared. So 36, 4 plus 25. So 36 and 29. 36 is greater than 29, so this would be an obtuse triangle. Number 2, again, C has to be 17 because it has to be the longest side. So 17 equals 8 squared plus 15 squared. 17 squared is 289, 8 squared is 64, and 15 squared is 225. So if we do 289 on this side If we add those together, we get 289. You see that those are equal. So this is going to be a right triangle because the Pythagorean theorem works. Okay, so now check out number 3. Number 3 is kind of special. If we look at that, all 3 side lengths are the exact same. So if all the side lengths are the same, it is equilateral. And if it is equilateral, that means it is equiangular. And if it's equiangular, we know that if there's 180 degrees in a triangle, and all 3 angles have to be the same, that all the angles each have to measure 60 degrees. So this also has to be an acute triangle. So you can either do it using the rules in this method, or you can explain the fact that this is an equiangular triangle, which also implies that it is an acute triangle. Another classification by the sides is also isosceles.